So the problem asks us to make a 3.6 molar solution and have the volume be 0.25 liters as opposed to 1 liter. Now if it was 1 liter, this problem would be much easier because we just add 3.6 moles and put it into a liter of solution. But because we're only making a quarter of a liter, we have to use our molarity and set up a ratio. Now we know 3.6 with a big M means if we had 1 liter, it would contain 3.6 moles of sodium hydroxide. So we're going to use this as a ratio. 3.6 moles over 1 liter equals X. We don't know how many moles over 0.25 liters. That's all we're making. We're only making 0.25 liters. So we're going to put less than 3.6 moles in there. We just don't know exactly how much. So cross multiply, 3.6 times 0.25 equals 1 times X, solve for X, and you end up with 0.9 moles. So we got 0.9 moles of sodium hydroxide that we're going to put in there. However, scales can't measure in moles, scales have to measure in grams. So we have to do a quick mole to mass conversion. We're going to take our 0.9 moles and we're going to cancel out moles, put 1 mole down here, and then we're going to look on the periodic table and look up the molar mass of sodium hydroxide. Now I also gave it to you in the problem, so if you didn't have it in the problem, you'd have to depend on the periodic table. But when you look up 1 sodium, 1 oxygen, and 1 hydrogen, you get 40 grams. So you do 0.9 times 40 divided by 1 equals 36 grams. So now you would go get your scale, weigh out 36 grams of sodium hydroxide, take your 0.25 liter, 250 milliliter flask, fill it about halfway with water, dump in your 36 grams, swirl it, dissolve it, and then top it off. Fill it all the way up to the 0.25 liter, or the 250 milliliter mark, and then you're all set. You have a 3.6 molar solution that has a volume of only 0.25 and not 1 liter.